So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the AQA Level 2 Certificate of Further Maths June 2023 Paper 1, which is a non-calculator paper. Now before we get started, a little reminder that if I have made any mistakes in this video, please check out the description to see any corrections are there, and I'll also include a question breakdown, so if there are any particular questions that you find a little bit challenging or not sure about, you can see what topic it refers to and then go back and review or revise this particular topic. And I'll also include a link to the 162 Maths contents page, which gives you easy access to online lessons, topic tests and all the other further maths walkthroughs. So let's get started on question 1. So question 1 says the function f is given by f of x equals 2x plus 1. And for part A, it's asking us to work out x when f of x equals minus 5. So for this, all we need to do is make the function equal to minus 5 and solve for x. So here we've got 2x plus 1 equals minus 5. Then to get rid of the 1, we take away 1. And that leaves us with 2x equals minus 6. And then we divide by 2 to get rid of the 2, and what we're left with is minus 3. Moving on to question B, it says the function g is given by g of x equals x squared. Work out fg of 3. Now if I just write down what f of x is from part A, and that was 2x plus 1. And so what we're doing here is, because we're working out f of g, I want to substitute g and replace that where I've gone x. So what I have then is 2 lots of x squared plus 1. And I want to work out the value of where I substitute 3 in. So if I just simplify this, this is the expression or the function of fg of x. So this leaves me with 2x squared plus 1. And then to substitute 3 in, we end up with 2 lots of 3 squared plus 1. That's 2 times 9 plus 1, which gives me an answer of 19. Moving on to question 2, it says factorise fully, and we've got 6x squared y plus 21xy. So what we want to look at is what is common in both the first term and the second term. So looking at the numbers, the highest common factor of 6 and 21 is 3. Both terms have got x, so we take out the lowest power of x, which is just a single x, and both terms have got a y, so I can take that out. Then what do I need to multiply this to get the first term? Well, I've got 3, but I want 6, so I need a 2. I've got x, but I want x squared, so I need another x, and I've got 1y and I want 1y, so that's absolutely fine. Then moving on to the second term, I've got 3, but I want 21, so I need a 7. I've got a single x and I want a single x. I've got a single y and I want a single y. So I can close the brackets, and that gives me my answer there. Moving on to question 3a, it says circle the transformation matrix that represents a reflection in the line y equals minus x. And the one you want to circle for one single mark, and it's just a case of memorizing these transformation matrices, and it's going to be the first one. Then for question 3b, now actually, let me just go back to question 3a. Now, how I do the transformation matrix is the fact that if I start by drawing the unit square, so here I've got 1 point and here I've got 1 point. Now, this is my point 1, this is my point 2. Now, the coordinate 1 is at 1, 0, and point 2 is at 0, 1, so that has got this matrix. Now, this is my OG matrix. Now, the line y equals minus x is this line here. Now if I reflect that line, then my new number 2 is going to be here, so let's call that 2 dash, and number 1 is going to be here. Let's call that 1 dash. So then the coordinates of what I then need to write is this is going to be 1 dash and this is going to be 2 dash. So 1 dash is now at 0, minus 1, and 2 dash is going to be at minus 1, 0, and that's the reason why option 1 is the correct choice. Now moving on to question 3b, we've got to multiply these two matrices, and we want it in the form of a number multiplied by the identity matrix. Now the identity matrix, if you remember, is equal to 1, 0, 0, 1, and so what I need to do is multiply this out. Now again, this is probably the most stingiest question in terms of marks available for the amount of work that's needed, particularly if you haven't got a calculator, and as this is a non-calculated paper, I can't use it. So let's have a look at multiplying this out. So what we need to do is we need to multiply this row by these two numbers here to find my first number. So that's going to be 2 lots of -3 plus 4 lots of 1. Then I'm going to multiply that by the second row. So that's going to be, let's use a different colour. So we're going to have 2 lots of -4 plus 4 lots of 2. Then I'm now going to move on to the second row. So I'm now multiplying this by that. And that gives me -1 multiplied by -3 and plus -3 multiplied by 1. And then the bottom number, let's use a different colour. We're going to do -1 multiplied by -4 plus -3 multiplied by 2. And then all that's left for me to then do is work these out. So -2 times -3 is 2 multiplied by -3 is -6, and then we end up with +4. So that gives me an answer of -2. This becomes -8 plus 8, which is 0. This then becomes 3 minus 3, which is 0. And this becomes 4 plus -6, which is going to give me -2. So then what have I multiplied this to get to this? Well, I've multiplied it by -2. So k equals -2. And that's going to be -2i. And there we go. Moving on to question 4, it says S has a coordinate of 7, 2, and T has a coordinate of 5, -4. Our points on a straight line, and for 4, 8 says work out the gradient of the line. So for this, what we need to do is recognise that M is equal to y2 minus y1 over x2 minus x1. And this is my x1, that is my y1, and this is my x2, and that is my y2. So substitute those numbers into that formula, get M value of, and it's going to be -4, and that's going to be 5, and we've got 2, and we've got 7, and I'm taking those two things away. So then working that out, got -4 minus 2 is -6, and 5 minus 7 is -2, which gives me a gradient of +3. Then moving on to question 4b, it says work out the distance between S and T. Give your answer in the form of A root B, where A and B are both integers greater than 1. So if I write down the coordinates again, so I've got S at 7, 2, and I've got T at 5 minus 4. And what we need to do is use the formula of distance between two coordinates as x2 minus x1 squared plus y2 minus y1 squared. Now if I substitute those coordinates into that correctly, I get a d value of the square root of 5 minus 7 squared plus -4 minus 2 squared. That's all square rooted, giving me a d value of 4 plus 36, which equals square root of 40. And then I want to simplify this using surds, so that then becomes root 4 times root 10, which leaves me with the answer of 2 root 10. Moving on to question 5, it says the xn and yn are the nth terms of two sequences, and we've got those two sequences there. And it says prove that every term of the sequence with the nth term of yn minus xn is a multiple of 3. So what we need to do is first of all substitute these into that expression like so. And what we end up with is yn, which is n plus 1 n plus 2 minus, now this is the important bit, is put this second one in square brackets. So I've got n minus 1 n plus 1. Now this, if you do the multiplication correctly, we get n squared plus 3n plus 2 minus, and this is going to give me n squared minus 1. And then all that's left for me to then do is just take away those wiggly brackets. So I've got n squared plus 3n plus 2 minus n squared plus 1. And then what you should notice here is that the n squareds cancel out. And what I'm left with is 3n plus 3. Then from this I can then factorise that. So I can take a 3 out. And as you can see, as 3 is a factor, each term will be a multiple of 3. And there we go. Now moving on to question 6, it says the equation of the curve is y equals x to the power 6 plus 4x squared minus 7. Work out the equation of the tangent to the curve at the point 1 minus 2. Give your answer in the form of y equals mx plus c. So for this, the first thing we need to do is the equation of a tangent is basically using differentiation. So here, the first thing we need to do is work out what dy over dx is of this expression. So remember, with differentiation, we move the power to the front, lower the power by 1. So that's going to become 6x to the power of 5 plus 8x. And from this, what we then want to do is we then want to substitute the x ordinate. So the gradient of the line, so gradient of the tangent is when dy over dx, and I'm substituting x equals 1. So that then becomes 6 lots of 1 to the power of 5 plus 8 times 1. And that's going to become 6 plus 8, which equals 14. So 14 equals m. Then all that's left for me to then do is then work out the equation of the line. So the equation of the tangent, and hopefully you're using this formula. So I've got y minus y1 equals mx minus x1. We've got m is 14, and we've got this coordinate here, which is my x1 and y1. So that then becomes y minus 2 equals 14 bracket x minus 1. Then expanding and simplifying, we get x plus 2. I was going to write 4 there. So x plus 2 equals 14x minus 14. Take the 2 over to the other side, and we end up with the answer of y equals 14x minus 16. Moving on to question 7, it says the diagram below shows a cone and a prism. All measurements are in centimetres. The cone has a base radius of r and a perpendicular height of x. The prism has a triangular cross section with a base of y and a perpendicular height of y. The length of the prism is x, and we've got the formula of the cone, and it says the volume of the cone is 4 times the volume of the prism, and the question is asking us to write r in terms of y. So let's just zoom out so we can see all of this in all its entirety. So what we need to do first is work out the volume of each of the shapes. So working out the volume of the cone, what I'm substituting, the area of the base, well, that's going to be pi r squared, and the perpendicular height is x. So substituting those in, I get a third multiplied by pi r squared multiplied by x. Now if I simplify all of that, what do I end up with? Well, I end up with v equals x over 3 pi r squared. I'm just going to put a little box around that. Then to work out the volume of a prism, it's the cross section divided by or multiplied by the length. So the volume of the prism is equal to the area of the triangle, which is y squared over 2, multiplied by the length, which is x. So if I then simplify all of this, I get the volume. Let's just write v equals xy squared over 2, and let's put a little box around that. Now in this little sentence here, it says the volume of the cone is 4 times the volume of the prism. So if you imagine these on scales, I'm going to need 4 prisms for it to balance with the volume of the cone. So I need 4 lots of the prism, so that's going to be 4xy squared over 2, and that is equal to the volume of the cone, which is x over 3 pi r squared. Now from this I can do a bit of simplifying. I can simplify the 4 and the 2, so that becomes a 2. So what I'm left with is x over 3 pi r squared equals 2xy squared. Now from this, what I then want is I then need to go on and simplify. Now from this, what I can do is I can cancel the x from both sides, and that's pretty much in terms of its similarity. Now again, because what I'm wanting is to express r in terms of y, so what that then looks like is it looks like pi r squared divided by 3 equals 2y squared. And what I want to do is I want to make r the subject. So using this, and let me just move across the screen, making r the subject, I take the 3 over, so pi r cubed squared rather equals 6y squared. Then I take the pi over, so r squared equals 6y squared divided by pi. And then I just need to remove the square, so it's going to be the square root of 6y squared over pi. And there is my answer. Moving on to question 8, let's just zoom in so we can see the question a bit clearer on the screen. It says that a circle has a centre 0, 0 and a radius of 5. A straight line has the equation of 2y equals x plus 5. And the question is asking us to work out the coordinates of the 2 points where the circle and the straight line intersect. Do not use trial improvement, you must show you're working out. Now whenever you've got two things intersecting, particularly on a graph, then what we need to do is we need to think of simultaneous equations. Now with simultaneous equations I need two equations. Now if I've got a centre with a centre of 0, 0 and a radius of 5, then that is going to have an equation of x squared plus y squared equals 5 squared. So my two equations I've got are x squared plus y squared equals 25, and I've got 2y plus equals, rather not plus, equals x plus 5. Now what I need to do is need to make one less to the subject. Now I could make y the subject by dividing by 2, but I'm going to be then working with fractions, which I'm not really wanting. So what I'm going to do here is I'm going to actually move the 5 over to the other side. So what I end up with is 2y minus 5 equals x. Now I've got x the subject. What I'm going to do is I'm going to substitute it into the equation of the circle. Now substituting it in, what I'm going to end up with is 2y minus 5 squared plus y squared equals 25. Now expanding this out, now recognizing that this is 2y minus 5, 2y minus 5 plus y squared equals 25. Now expanding this out and simplifying, I'm going to get 4y squared plus, and that's going to be 20, or no, it's going to be minus 20y rather, minus 20y plus 25 plus y squared equals 25. Then from this, what I can then do is simplify, and I get 5y squared minus 25, or 20y, minus 20y, and I take the 25 over, and that's going to equal 0. Now from this, what I then want to do is factorise. So I can take 5y out, in which I end up with y minus 4 equals 0. And that's going to give me a y value of either 0 or 4. Now from this, what I then need to do is find the respective y values. So if I take this box and substitute those numbers in, then what I end up with is when y equals 0, I end up with 0 minus 5 equals x, x equals minus 5. So that's one set of coordinates. Then when y equals 4, I'm going to end up with 8 minus 5 equals x, so x equals 3. And there is my second coordinate. And so all I now need to do is just write down the answers. And remember that if you are writing your answers as coordinates, you do not get the x and the y values muddled up. So then the solution, or the intersection points, are going to be 3, 4 and minus 5, 0. There we go for that one. Moving on to question 9, we're asked to rearrange this formula of what w equals y squared plus 5 over y squared minus 2 to make y the subject. So for this, what we need to do is take the denominator over to the other side, in which we end up with w y squared minus 2 equals y squared plus 5. So it just eliminates that fraction. Now if I expand the brackets out, I end up with wy squared minus 2w equals y squared plus 5. Now if I get everything with a y on one side, everything else on the other, so what I'm doing is taking this to this side and taking that to that side, and I end up with wy squared minus y squared equals 5 plus 2w. Then if I factorise the left hand side, I end up with w squared, and then it's going to be w minus 2 equals 5 plus 2w. Take this bracket over to the other side, so what I end up with is y squared equals 5 plus 2w divided by w minus 2, and then I can square root it, so y equals the square root of 5 plus 2w over w minus 2. And there is my formula for that one. Moving on to question 10. It says rationalise the denominator and simplify fully. So to rationalise the denominator, what I need to do is need to multiply this fraction by 3 plus root 5. So if I do that, I end up with 1 plus root 5 over, multiplied by 3 plus root 5 over 3 minus root 5 and 3 plus root 5. Now if I write down what that equals, well, 1 times 3 is 3 plus root 5 plus 3 root 5 plus root 25 all over 9 minus root 25. Then if I simplify the numerator, I end up with 8 plus 4 root 5. And simplify the denominator, that's going to equal 5, so that's going to be equal to 4. And then I can cancel the 4 with a 2, and so all I'm left with is 2 plus root 5. Then moving on to question 11. So question 11 says y equals 1 over 12 x to the power 4 plus 3x squared plus 4, and the question is asking us to work out the positive value of x for which the second derivative is equal to 55. So first things first, what I need to do here is work out the first derivative. So dy over dx. So again, move the power to the front, lower the power by 1. So that's going to be 4 over 12 x to the power 3 plus 6x, and that's it. Then if I simplify this, I can get 1 over 3. So then from this, what I then want to do is work out the second derivative. And so 3 times a third is just 1. So I'm just left with x squared, and that's going to be equal to plus 6. So what I can then do is then make this equal to 55. So x squared plus 6 equals 55. So then x squared equals, take the 6 over to make it 49. So x equals minus 7 or positive 7. But the question says work out the positive value of x. So I can get rid of the minus 7 and keep the positive 7. Moving on to question 12, it says write down the value of x for which x is inclusive of 0 to 360 when sine x equals minus 1. So for this, if I draw my sine graph between the regions of 0 and 360, I end up with something that looks like this. This is at 1, this is at minus 1, and from this I'm looking for where this line touches. It's at this point here. This is at 0, that's at 90, that's at 180, and that's at 270. So the answer then is 270. Moving on to question 12b, it says work out the values of y when root 3 tan y equals 1. So first things first, what we want to do is we want to get tan y as subject. So tan y equals 1 over root 3. Now from this you should know and recognise that 1 over root 3 is an exact value of trig, and that's when y equals 30, then if I use the trig graph, that it looks something like this between the region that I've got. And I'm looking for when this line here is when I've got 1 over root 3. So this value here is at 30. So the next time it hits that point is here. And that point there is at 180. So what I need to do to find that second value is to do 180 plus 30, which equals 210. So the answer to this question is going to be 30 degrees and 210. Moving on to question 13, we've got another algebraic fraction. So it says write 2x minus 3 over x minus 1 over 3x plus 1 as a single fraction. So what we need to do is try and get a common denominator. So if I just write this out first, oh, don't know where I've wrote an equal sign, let's get rid of that. Minus 1 over 3x plus, and I'm going to write this as a fraction as 1 over 1. So here my common denominator is going to be 3x. So I want to write this over 3x, this over 3x, and this over 3x. So multiplying to get this first fraction as a denominator of 3x, you need to multiply that by 3. So let's write, it's going to be 3 lots of 2x minus 3. This second fraction is absolutely fine because that's already got a denominator of 3x. And then the last fraction, I need to write that as 3x over 3x. Then if I look at the numerator of all of those, because I've now got a common denominator, I just want to do the maths on that. So I end up with expanding the brackets. I get 6x minus 9 minus 1 plus 3x. And that's all over 3x. So then simplifying the numerator, what I'm going to end up with is 9x minus 10 over 3x. Then just do a little check. Can I simplify that? No, I can't. So I'm going to leave it as that. And again, we don't want to split that fraction up because the question does ask us to write it as a single fraction. Then moving on to question 14, it says solve 8 over x plus 3x is less or equal to 10 where x is positive. So for this, what we want to do, if I just start off by writing this out, I always find it more comfortable if I've written it in my own handwriting. So for this, what I want to do is I want to write this all as a single fraction. So to write that as a single fraction, I get 8 over x plus 3x squared over x, and that's less or equal to 10. So now I've got a common denominator to write as a single fraction, so that's going to be 8 plus 3x squared over x is less or equal to 10. Take the x over to the other side, and what I end up with is 8 plus 3x squared is less or equal to 10x. And then from this, what you should be able to spot is this is now turning into a quadratic equation, or inequality, I should say. So that then becomes 3x squared minus 10x plus 8 is less or equal to 0. Now from this does factorise, and particularly as it's on a non-calculated paper, so you won't be expected to use the quadratic formula, but it does factorise to become 3x minus 4 and x minus 2, and that's less or equal to 0. So now if I find the solutions, that's x equals, and that's going to be 4 over 3 or 2. Now if I do a little sketch of this, the parabola looks something like that, where this is y and this is x. Now these 2 points are where it crosses the x-axis. That is 4 over 3 and that is at 2. And what the region that I'm wanting is this region here. So to write that as an inequality, that's going to be 4 over 3 is less or equal to x is less or equal to 2. And that there is my solution. Moving on to question 15, it says solve, and we've got x to the power of a half minus x to the power of 1.5 squared equals x squared plus x. So for this, what we need to do is first of all establish that this is a double bracket question. So you can't just simply square both sides because it doesn't work that way. So this is the same as x of a half minus x 3 over 2, x to the half minus x to the 3 over 2, and that is equal to x squared plus x. Now, simplifying this, remember when we add multiplying, we add the powers. That's going to give me x to the power of 1. Now, a half plus 1.5 is 2. So that's going to give me minus x squared. This is going to give me another minus x squared. And this is going to give me plus 1.5 times 1.5 is 3. So x to the power of 3. And that's equal to x squared plus x. So then what I've got to do is now simplify this. So what this then becomes is x minus 2x squared plus x cubed equals x squared plus x. So then the x's cancel out. And then from this, if I take this over to the other side, I end up with x cubed equals 3x squared. Then from this, what I then want to do is not divide by x. I want to take it all onto one side. So that becomes x cubed minus 3x squared equals 0. Factorize this. So that take x squared out. And that leaves me with x minus 3 equals 0. And then I can solve. So either x equals 0 or x equals 3. Now moving on to question 16, it says the expansions of 1 plus 12x to the power of 4 and a plus 4x to the power of 3 have the same coefficient of x squared. Work out the value of a. Now this one is going to be quite complicated in terms of how we do this, but for 4 marks, let's see where we go. So the first thing I'm going to do is I'm going to work with this expansion here. So if I just label this as 1 plus 12x to the power of 4. Now I always treat this as each term is going to have 3 components. So I've got 4 to the power of 0. And then this first term is 1, that starts high, and the second term starts low, 0. So then I'm doing 4, 1 multiplied by x to the power 3 multiplied by 12x 1, and then 4, 2 multiplied by 1 squared multiplied by 12x 2. And this is what my coefficient of x squared is going to be. So that is what I'm wanting to work with. Now if I do Pascal's triangle, let's just do this here. So I've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now 4, 2 is using this line here. Now remember that with the Pascal's triangle, the first term is 0. So that's 0, 1, 2. So I want the 4th row and the 3rd number. So that's going to be 6. That's 6 times 1 multiplied by 144x squared. So simplifying all of this, 6 times 144 gives me 864x squared. Then if I work with the second term, which is a plus 4x cubed. So again, I end up with 3, 0 multiplied by a to the power of 3 multiplied by 4x to the power of 0. Then it's 3, 1 multiplied by x squared multiplied by 4x to the power of 1, and 3, 2 multiplied by a 1 multiplied by 4x squared. And it's this line that I'm wanting. So if I pick the 3rd row, which is here, and remember the first row is 0, so 1, 2, 3, and I want the 3rd number, and that is a 3. So this is going to be 3 times a multiplied by 16x squared. So simplifying all of this, 3 times 16 gives me 48, so that's 48ax squared. Now it says in the question that the coefficient of x squared is the same, so that means that 864 is equal to 48a. So 684 equals 48a. So a equals 864 divided by 48. So then I might do I won't say necessarily long division, but if I divide both numbers by 2, I get 432 divided by 24. I can then divide by 2 again, so that's 216 divided by 12. I can then divide by 2 again, so that's going to give me 108 divided by 6. And then I can just, it slowly starts to make this a lot easier. So I've got 6 over 108. 6 goes to 1, none. 6 goes into 10 once, remainder 4, giving me an A value of 18. Now moving on to question 17, it says the curve y equals ax cubed plus bx squared plus 7 has a stationary point at minus 2, 11. Work out the values of a and b. So for this, first thing we need to know, we'll first work out is dy over dx. And working dy dx of this equation, we get 3ax squared plus 2bx. Now, from this, what we know is that because it's a stationary point, we know that dy over dx equals 0 when x equals minus 2. So if I substitute x equals minus 2 into dy dx, then let's have a look at what we get. Well, we're going to get 3a minus 2 squared plus 2b multiplied by minus 2, and that equals 0. So simplifying all of this, minus 2 squared is positive 4, so that becomes 12a. 2 times minus 2 becomes minus 4, so that's minus 4b equals 0. And that's one equation that I've got there. Now, looking at the second bit of information, I know that I can substitute these values into this equation. So minus 2 is x and 11 is y. And what I end up with is 11 equals a, and it's going to be minus 2 cubed plus b minus 2 squared plus 7. So from this I get 11 equals minus 2 cubed is minus 8, minus 2 squared is positive 4 plus 7. I can take the 7 over to the other side, so I end up with 4 equals minus 8a plus 4b. Now if I keep those equations and don't simplify them, then what you can see is I've got two equations involving a and b, and they're the two values that I want. So what I now need to do is think about simultaneous equations. So look, taking the bigger coordinate, so I've got minus 8a plus 4b equals 4, and I've got 12a minus 4b equals 0. So here you can see I've got the same number of b's, the signs are different, so I need to add the two equations. So minus 8 plus 12 is 4a, the b's cancel out, and 4 plus 0 is 4. So that means that a equals 1. So now that I know the value of a, if I use this equation, so using 12a minus 4b equals 0 and a equals 1, I get 12 minus 4b equals 0. So minus 4b equals minus 12, so b equals 3, and there are my values for a and b. Moving on to question 18, it says solve the simultaneous equations, do not use trial improvement, and you must show your working out. So for this we've got a triple simultaneous equation, a lot of simultaneous equations on this particular paper, but that's how we go. So what we want to do at this is that we want to try and have either the same number of x's or the same number of y's. Now what I notice in this particular set of equations is that not each of the equations has x and y. So what I want to do first is I want an equation that just involves x's and y's. So if I take, let's say I'm going to take this equation here. Actually, let's not do that. Let's highlight it. So if I take this equation here, I can rewrite this as that z equals, and it's going to be 2y minus 7. Now, if I then substitute that into the second equation, what the second equation then becomes is x plus 3 lots of 2y minus 7, and that equals 2. Now, if I simplify all of that, I end up with x plus 6y minus 21 equals 2. Take the 21 over and end up with x plus 6y equals 23. Now if I take the first equation this equation here, what I then end up with is 2x plus y equals 13, and I end up with x plus 6y equals 23. If I multiply this top equation, or that's actually the second equation, by 2, I'm going to end up with 2x plus 12y equals 46. If I write down this equation here, I get 2x plus y equals 13. Now from this I can then use simultaneous equations to work out what x and y are. So here I take away the equations because the x's are the same and they're both the same sign, so that disappears. 12 minus 1 is 11y, and 46 take away 13 is 33. So that gives me a y value of 3. Now from this, if I take either equation, let's take this one here, I end up with 2x plus y equals 13. I know y equals 3, so that then becomes 2x plus 3 equals 13. So 2x equals 10, so x equals 5. Now I know the value of x and y, I can now work with one of the other equations to work out what z is. So if I take this equation here, x plus 3z equals 2, I know that x equals 5, so that becomes 5 plus 3z equals 2. 3z is going to equal to minus 3, so z equals minus 1. And there gives me my three values. So x equals 5, y equals 3, and z equals minus 1. Moving on to question 19, it says 8x squared plus 20x plus n is identical to c lots of x plus d squared plus 3, where c, d, and n are constants. Work out the values of c, d, and n. So for this, what we want to do first is compare the coefficients. Now, if I take the right hand side, let's expand the brackets. So I end up with 8x squared plus 20x plus n. Now if I simplify that, we'll do it in stages, so that then becomes x squared plus 2dx plus d squared plus 3. Multiply everything in the brackets by c, and I get cx squared plus 2cdx plus d squared, or should we cd squared, cd squared plus 3. Now if I introduce the left hand side back again, what I want to do now is compare the coefficients. So the coefficients of x squared, well, I've got a lots of x squared on this side and I've got c lots on this side, so that means that 8 equals c, and that is one of my values. If I then look at the coefficient of x, then I've got 20x on the right hand side, left hand side, and on the other side everything with an x is just 2cd, so I've got 2cd. Now I know that c equals 8, so 20 equals 16d, so d is then going to equal 20 over 16, which is 5 over 4. So that's my d value. Now it doesn't say that d is an integer, it just says it's a constant. So I'll accept it for what it is. And then finally, looking at the constants, so the coefficient of the constant is on the left hand side, I've got n, and on the right hand side, I've got cd plus 3. So here I've got n equals cd squared plus 3. I know the values of c and d, so n equals, and it's going to be 5 over 4 squared multiplied by 8 plus 3. Now this looks a bit complicated, but if I square the 5 over 4, that becomes 24 over 16 multiplied by 8 plus 3. Don't know what's happened there. Plus 3. And then from this, what I then want to do is just neaten this up. So you can either do 8 times 25, which is 200 over 16, or you can cancel this down to to 1, and that becomes a 2, in which then we end up with 25 over 2 plus 3. 25 over 3 is 12.5 plus 3, which equals 15.5, and that is all equal to n. So C equals 8, D equals 5 over 4, or you can write it as 1.25, and n is 15.5, or you can write it as 31 over 2, whichever you prefer to write it as. Then moving on to our last question, it says P, Q and R are points on the circle with centre O. Angle POR is equal to 120, PQ is equal to 4 centimetres and QR is equal to 5 centimetres. And the question is asking us to work out the radius of the circle. Give your answer in the form of root K, where K is an integer. So if I just zoom out just so that we can see the question in all its entirety, let's have a look at what we know. So for this, we can see that this question here, this triangle of POR is an isosceles triangle. So if I take the large triangle out, and what I mean by the large triangle, I mean this triangle here, then you can see that we've got an arrowhead, and with the arrowhead, which is here, that what I know is that this angle of Q is half the size of the angle at POR, so that's going to be 60. So if I take that large orange triangle out and I just label the points, that's P, that's Q, that's R, and this is 60, I know that this is 4 and this is 5. So what I can then do is work out what this is. Now to do from this triangle, I need to use the cosine rule, in which what I know is that x squared equals 4 squared plus 5 squared minus 2 times 5 times 4 multiplied by cos 60. Now from this, if I simplify all of that, remembering this is a non-calculator paper, we get x squared equals 16 plus 25 minus 2 times 5 is 10 times 4 is 40, and cos 60, well, that cos 60 is a half. So 40 times a half is 20, so x squared equals 16 plus 25 minus 20. 16 plus 25 is 41. Take away 20 is 21. So x squared equals 21, so x equals square root of 21. So this length here is root 21. Now if I take that second triangle, like so, this is a really poor diagram, I know that this is P, this is O, and this is R. I know this length here is 21. I know it's an isosceles triangle. So from this, what I can then do, I know that also know that this angle here is 120. So if I split this in half, this then becomes a right angle triangle. This angle here becomes 60, and this length here becomes root 21 divided by 2. So if I take that triangle out, what I end up with is this, where this is P, this is O, this is root 21 over, this is root 21 over 2. This is 60, and this is what I'm after. So I'm after that length there. Now from this, because that's the radius of the circle, so let's just call that R. Now from this, what we can then do is label the triangle. So I've got, this is my opposite, this is my hypotenuse. So which trig ratio uses O and H? Well, that's going to be sin. So I've got sine 60 equals opposite over hypotenuse, which is equal to root 21 over 2 divided by R. And sine 60, well, sine 60 is an exact value of trig, which is root 3 over 2. So what I end up with is, and I'll do this over here, is I end up with root 3 over 2 equals root 21 over 2 all divided by r. Now if I take the r over to the other side, I end up with r root 3 over 2 equals root 21 over 2. Now from this, what we can then see is that the 2's cancel out. So r root 3 equals root 21. Root 21 can be written as root 3 times root 7. So I can write this as r root 3, and that's going to be root 7 multiplied by root 3. So that means that r equals root 7. And so the radius of the circle is root 7. And there we go.